Hi everybody, so we're going to continue from the part 1 of the introduction to statistics. Last time we mentioned that when you're making your conclusions, the statements should be easy to understand to those people who haven't taken any course in stats or understanding its terminologies. Secondly, for your conclusions, we cannot make any conclusion without doing statistical analysis methods. Implications, we also need to imply any implication in reality. So we need to state practical implication of the results. Over here, we would like to talk about two differences, the differences between two significance. One is called statistical significance, and one is called the actual practical significance. So when we talk about these two significances, the common sense might suggest that the finding or treatment does not make enough of a difference to justify its use or to be practical in reality. So here we would like to talk about statistical significance. What is the statistical significance? So basically, we are trying to see if the event or result is easily occurred. Okay, so consider the likelihood of getting the results by chance. If the results could easily occur, then they're not statistically significant. So results easily occur, then they are not statistically significant. If the result is not easily occur, okay, if the likelihood of the result is small, then the result is actually statistically significant. Let's look at the next example. You may take a pause to read the problem and we'll come back. Okay, so you must have read the problem. Okay, let's talk about Weight Watchers program, Weight Watchers weight loss program, right? Weight loss program. And it says on average, 40 subjects lost an average weight of 3 pounds. Okay. 3 pounds. Oopsie. Where's my marker? Lost a mean weight of 3 pounds after 1 year. And methods of statistics can be used to verify the diet is effective. So question 1, does the Weight Watchers weight loss program have statistical significance? Well, since the methods of statistics has been used, which means they've used statistical analysis to verify it's effective. So yes, it is statistically significant. Question 2, does it have the actual practical significance? So let's think about this question. If you lose an average weight of 3 pounds after 1 year, do you think this is actually significant to you in reality? Not really, right? So no. Oopsie. So no, not practical significant. So next example, I'll let you guys read it. Take a pause, please. Okay, so you must have read it. And the question asking you, they've got the results of 26% having yellow pads, right? 26%. While the theory says 25% should have yellow pads. So the question is this 26% statistically significant? Let me do the marker here again. So 26 is actual result. 25% is by the theory. So we're asking if this is statistically significant. So in reality, when you think about doing the experiment, right? So 26% is likely to occur. It is easy to have an experiment to have 1% differing from the 25%. If this is easily occurred, then it is not statistically significant. Right? So the idea here is if this result is easily occurred, can be easily occurred, then it is not statistically significant. So next, let's talk about types of data. We have, first of all, two terms. One is called the parameter, one is statistic. So a parameter is a numerical measurement. Parameter is a numerical measurement describing the characters of population, while statistic is a numerical measurement describing characteristic of a sample. So we're going to use the Venn diagram that we used before to show the difference between the parameter and statistic. Here is population, and here is the sample taken from the population, hopefully to be representative. From the population, you can get some numbers. Those numbers are called parameter. For a sample, you can also get some numerical measurements or numbers. Those are called statistic. Okay. So let's look at the following three questions. I'll give you a minute to think about it. You may take a pause. Okay, let's come back. So the first one says a large sample of households, and they got income, median annual income per household is 19,000-ish. So the 19,856 comes from sample. That is going to be a statistic. So statistic. Okay. Question 2, this is among all the senators in the current Congress, 44% are Democrats. 44% is talking about from all, which means from the population. Therefore, this is a parameter. Next one, a study of all 2,223 passengers found that 706. So 706 comes from the population. This is going to be a parameter as well. So the way you identify a statistic and a parameter is looking for whether it comes from sample or comes from population. Usually population is referring to all. Alright, over next we're going to talk about data, the different classification of data. First of all, data can be classified into two ways. One is called categorical, one is called quantitative. Categorical data can be placed into different categories. Sometimes it's called qualitative, so categorical is also called qualitative. Such as, okay, so examples such as gender, major, right, and religion, belief, religion. Those ones, you can all put them into different categories, so those are called categorical data. While quantitative data basically has to be a number. So quantitative data consists of numbers representing counts or measurements. Okay, let's look at the next question. I'll let you guys take a pause real quick. Okay, let's come back. First of all, the gender, this is typical categorical, right? Because it has to be either female or male. B, number of yards, it has to be in numbers, so quantitative. Third one, the numbers, right? Numbers, so this is also quantitative. Okay, next for quantitative data, which is number, using the round numbers, they can further be classified into two groups. One is called discrete data, one is continuous data. Okay, so discrete data, a lot of times they are discrete numbers, which means they have to be finite numbers, whole number integers. So whole numbers, finite, whole numbers, while continuous data can carry decimal, can have decimals. Okay, continuous. All right, so next one talks about differentiating between continuous or discrete. So if you look at it, it's very simple. The first one talks about the weight, right? Weight is going to be continuous because it carries decimals. So continuous. While the second one, the car is randomly selected and the car has 6 cylinders. So 6 here is talking about the number of cylinders. It has to be a finite number. This is going to be discrete because you can't have 6.1 cylinders, right? The other way to simply classify data is put them into different levels of measurement. Okay, so use levels of measurement. In total, there are 4 of those levels. Okay. And we're going to talk about them one by one. First one is called nominal level. So nominal basically is talking about these data could be put into different groups of categories. So it's like categorical data. Okay. And these data cannot be arranged in an ordering scheme. Okay. So we can do race and gender and religious preference. You cannot order these, right? You cannot rank those. And yet they're still put into different categories. The second one is ordinal level. Okay, ordinal level. Ordinal level is, the second one is called ordinal level of measurement. In ordinal, we're going to pay attention to the order. Order matters, which means you can rank these data. Okay. Like course grades, they can be put into A, B, C, D, F, and you know A is better than B, B is better than C, and so forth. School rankings, 1, 2, 3, 4. 1 is better than 2, probably. Well, if you say 1 is the best, then 2 is the second, right? So these are the ordinal level of measurements. Ordinal level can be arranged in some order. The following one is called the interval level. Okay, interval level. So interval level of measurement is kind of like ordinal. It ranks data, but there are the very specific differences between units. And there is no meaningful zero. I would like to emphasize this piece. When you say no meaningful zero, what does it mean by meaningful zero? Meaningful zero means none, nothing. So for example, okay, temperature, right? If temperature equals to 0, does that mean there's no temperature? No, it doesn't mean there's no temperature, right? There is still temperature. So this temperature has no meaningful 0. If it doesn't have meaningful 0, then this is going to be interval level. Same for year. If year equals 0, does that mean there's no year? No, it doesn't make sense for us to say there's no year. Therefore, year does not have meaningful 0. Year is an interval level. Okay, we're going to stop at here and we're going to talk about the third part of the measurement.